So do we need to go over 11.4? Do you want me to do anything up here with it? Or you think just getting that will help you out? Okay, well, I'm in my, I'm here, I gotta still do my class, but if you stick around with my basic algebra class, I might get to have time to help you. So we'll see. Okay, do we need to go over everything in 11.3 or 11.4? Those were last time's homework assignment, so anything there? Oh, yeah. Yep. What page was that? Okay. 905. You ran across one of those in your homework? Okay. I think it's just that your answer is going to be, probably works out to be 25. Let me double check here. Two. Okay. What we got to do is, it's kind of like a double connection piece in here. And so first off, we need to get it set equal to its exponential value. And so we get 5 to the x from this log. This is the base, this is the exponent, and this is the answer. Okay. Then if we take this piece and we end up reversing it, so then I have 5 to the 5 to the x is equal to 25. And now I can get my bases to match. So if my bases match, but that's not going to give me my correct answer. Two-fifths, but the answer that they came up with was that one. Let me dig. I had thought we had pulled all of those out of there. That you weren't supposed to get one of those, but things do happen. There were several of them. Oh, that's not good. Oh, this is the piece I'm missing, is right here. It's 5 to the x equals 6 log, not 6, 5. Log 5, 25. And then we say x is equal to log 5, 25. And then I end up taking and get 5 to the x power is equal to 25. And then I find out that 5x is equal to 5 to the second power, and x is equal to 2. I missed the one section with this piece. Okay, so let's go back through this. So if I take this piece that I have right here, this is my base, this is my exponent, this here is my log piece. That's what it's equal to. So then if I take a look at this, then what I have is x is equal to that as an exponent. So then I take this x and this piece, set those two equal to each other, and then I need to reverse it. So 5 to the x power is equal to 25. And then finally, take 25, break it down to 5 squared, and I end up with these two exponents equal to each other. So I get x is equal to 2. So let's take another look at a different one of those. And let's do the next one that was listed in there. So let's see what we do with this next one. So log 4 log 2 8 equals x. So if I reverse this, I have 4 to the x power is equal to 4 log 2 8. We good there so far? So basically I'm taking my base to my exponent is equal to what this happens to be. So now since both of my bases are 4s, they match each other. So then I need to set my exponents equal to each other. So then if I reverse this one more time, 2 to the x power is equal to 8. 2 to the x. 8 can be broken down to 2 times 2 times 2. So I get 2 to the third power. Since my bases now match, x is going to be equal to 3. So that's what would be in that place up there, is 3. Want one more? Want one more? Okay. Here's one more. Log 6 log 4 16 equals x. So my base, my exponent, is equal to the answer, which is 6 log 4 16. Okay, following? So far so good, hopefully. Bases match. So since they match, I can set these two pieces equal to each other. So x equals log 4 16. So then if I reverse this, my base is 4, my exponent is x, equal to 16, because I've reversed my log. Okay, even though it looks backwards, we're still going back and reversing that log back to exponential form. Then take 16 and break it down to 4 squared, because I want my bases to match here. So x is equal to 2. So that would be my answer to that one. All right. Yes or no? What do you think? Better? Maybe? Okay. Okay. Because you gotta to again reverse these. They look kind of ugly because you got all of this stuff up here and things. But sorry I left that out the other day. I thought we had pulled those, but I guess we didn't. So that's that piece. So I will make sure I put more in my notes next time for the next go around with that level. Okay, and that was in 11.4 was where those were. Okay, we good with that part, you think? Or you need to do another one? We okay? All right. So if you didn't get your homework assignment done, just let me know. If that held you back and that was the piece that you didn't get it done, let me know and I'll fix that for you with your homework part, because that was my fault. I didn't plug one of those in there and show you what you had to do with it. Okay. Anything else in 11.4? Okay. We ready to go on then to 11.5? I got a couple of you. I need to get your sheet because we got to talk about this stuff on that one. Yeah, where this was from Monday. That was from Monday. Okay, section 11.5 is taking a look at properties of logarithms. And so we got more properties. So if you go to that sheet I gave you on Monday, that sheet had not only the properties from 11.4, and a lot of these we turned them back into exponential form and we can solve our answers with those. These, on the other hand, are ones we're going to use. So as we go through these are documented on that sheet. So you don't have to write like crazy in trying to get those properties on there. And we're going to talk about each one separately. So there's 3 of them that are in here. And as we go through those, you'll see how they start relating to what we do have to do with our numbers and with our values for these. So let's get started on 11.5. And so in 11.5, we are going to understand the rules of changing the form into logarithmic expressions. And then we're going to use the rules to change the form of a logarithmic expression to evaluate logarithms. So the evaluation is going to be, of course, what something is equal to. And they will always, in this, give you what your log value is equal to. So you won't have to find that part. And we'll talk about that more as we go. Use the rules to expand the logarithmic expression and write expanded forms into single logarithms. So we're going to expand them out and then we're going to put them back together. So we're going to end up with our pieces that happen to fit into that. So using your calculator to find the values of logarithmics is discussed in the next section. But to illustrate some of the properties, we're going to give you some values that these things are going to be equal to, and we're going to play around with those for a little bit and see what we can come up with for answers to some of these. So we're going to use these. Now in your homework, they will give you values of these and ask you to expand your logarithm out and come up with an answer to it. These will be posted in your question as it comes up in Hawks. So you will see what these values happen to be, and when you run across that, if you're solving one of these, you will plug that number, this value, to the 4th decimal place in its location. And it'll make more sense in a second here. I know this is kind of sticking this piece in there, and it's not really maybe in the exact spot and exact location of where it needs to be. But the product rule, it says also because logarithms are around 4 decimal places, there's a slight difference may occur in answers if a calculator is used to find logarithms in some of the illustrations. Now the reason is your calculator will calculate things out to 11 places, and you may not round until you get to the final end. So that's why some of our answers today, then when we use those values that we were given over here, would come out differently than if you plugged it into your calculator to calculate those out. So that's that piece. So our first rule, our first logarithmic product rule says again, B has to be greater than 0, cannot equal 1, because we found that out the other day. If it were equal to 1, what happened? The exponent was raised, 1 was raised to an exponent, it always stayed as 1. And at the same time, y needs to be bigger than 0 because we've got 2 different values that were given in here. So if you look at this, this is the one that's on your sheet that I handed out to you. It had those listed. If we expand it, it means I've got a multiplication happening here. So if you have a multiplication going on, you're going to break this apart into 2 pieces because I have an x value and I have a y value. And whenever it's a multiplication, to expand it, it's going to become an addition. And that's just the rule. That's the law, or that's the thing that follows along with that. And so it's just what happens to be there and what we end up doing with that. So it's a plus sign and it's in there. Notice log B became part of my answer to each piece. So I will have log and whatever this base happens to be along with that answer, if I was going to turn it back into exponential form, is going to end up being at that spot. So the logarithm of a product is equal to the sum of the logarithms of the factors. So if we have factors in there, that's what happens. So what do we do with these? So if I had this, for instance, if I had log 10, 1,000. The other day, what we did with this is we went through and we set this whole thing equal to x. So I just want to kind of tie it back to what we were doing. So I ended up with 10 to the x power equals 1,000. Remember when we did that? what would x be? So 10 to what power would give me 1,000? So x would equal 3. Okay, so x equals 3. So we know that it's going to be something in relationship to 3. Now in today's assignment, we're going to look at this not as exponential form, but we're going to look at it as log 10. We might take 1,000 and break it into 10 times 10 times 10. So then if we took this and expanded it out into expanded form, then what would we end up doing? Well, we would end up having log 10, 10 plus log 10, 10 plus log, 10, 10. And what did we learn the other day when we have 10, 10? When these two matched each other, we had a value that was associated to that of 1. So this was 1, this was 1, and this was 1. So notice I get 1 plus 1 plus 1, or I get an answer of 3. So it worked out to be what I found in the exponential value, that it was ended up being 3. Now the ones we worked with on Monday were ones we could get an exact answer to. They were ones that came out to be an exact value. Some of the pieces today won't work out to be exact answers, and so that's why if we expand these out and we use these values, I'm going to try to get these values up here so we can see them at the top, we can end up taking these numbers of 30 and I can break it into multiples that use these things. So if I looked at 30, 30 is 5 times 6. So I have a 5 and I have a 6. So I could break this up to log 10, and I could have 5 times 6 is equal to 30. Now, when you have these type of problems, that's what you're going to need to do is break them apart. So then what does this come out to be? Well, it comes out to be log 10, 5 plus log 10, 6. And so then I can put my answers that they give you. These will be given to you in your problem. You can just substitute what the value happens to be. So log 10, 5 is 0.6990. Log 10, 6 is 0.7782. And just simply take those two, add them together. So if I grab my calculator and I add those together, what would my answer be? Now, this answer is not going to be an exact value because these two are just, of course, the rounded off representation of what those happen to be. So I add them together. And I get 1.4772. So that becomes my solution, all right? So that's what I would put in for these for my answer if I were going to do this with Hawks. Now, not all of these in this whole section do you do this with. We don't always break them apart. It's just some of them they give you examples of what they would end up equaling. So then what did they do? They gave you another one that was log 1030. Because if you look at 6, 6 could have been 5 times 2 times 3. So I could break that down to 2 times 3 to be my 6. If I expand this out, I'm going to have log 10, 5 plus log 10, 2 plus log 10, 3. And then I'm going to put my answers or my values that they give me up here in place of each. So log 10, 5 is 0.6990. Log 10, 2 is 0.3010. And log 3 is 0.4771. And if I add all those together, I'm going to still end up getting that answer, hopefully. Pardon? Is it different? So 0.6990 plus 4.3010 plus 4.771, and it came out completely different. And it was, oops. Oh, okay. Well, we'll bring it back up. 10,000? Okay. Yeah. And the reason probably that it's that way, it's not off by much. What would cause that to be off? Why would it be off by 1? So it would cause it to be off by maybe rounding. Okay. These two that we used up here may have been rounded like they were, but the numbers at the tail end of each of these cause one of them to go up. The number here that was in the 5th position for these two didn't cause it to change. And so that's why it can be off by just 1. I mean, I'm not counting that as very much because it's really off by only 1/10,000th, 1/10,000th, which is not very much. Okay. Now, if you're in machining, that's a lot, but for us, it's not that bad. Okay. So it's not a big change to that. So you're plugging these guys in to hold those positions when we expand it out. Okay. Now, again, not all of your problems do this. There's only a certain number in there that will expand your stuff out. So then the next rule, I can get rid of these guys. Well, let's see. We might leave them in there one more time here, is the quotient rule. And the quotient rule is stating that if I have something divided by something, so this is division. If it's divided, I'm going to use subtraction when I expand it out. So whenever you look at this, here's my base, my log, my base. These two are dividing, x divided by y. Whenever you see this division piece happening, you're going to do a subtraction in there. So we're going to subtract those two values to end up coming up with what your answer would be. Okay? So you want to watch that and make sure you get your values in there and get your subtractions to go. So again, so if it's a difference between the logarithm, so if your quotient is equal to the difference meaning, of course, subtraction, between the logarithm in the numerator and the logarithm in the denominator. So we've got subtraction taking place there. So let's see what we can do with this one. So what happens with this piece, so let me get my little numbers back up here because I think we have to figure out and calculate out what this value would end up being. So expanding it out would be log 10, 1 minus log 10, 2. Okay, so what do we end up with for answers in here? So it's kind of thrown back to 11.4 because we have to go, this one, what is it equal to? That's one of our rules from the previous section. So it's equal to 0 minus what log 10, 2 is equal to. So I'm going to minus 0.3001 away from that. And so 0 minus that gives me a negative 0.3010. Okay, for my answer to this one. So it's not hard. These are not bad as long as you remember division means to subtract. Multiplication means to add. And you get those straight, you're pretty much good to go with what you got to do with those. So let's take a look at this next one. What happens to it? So if I expand this out, I end up with log 2 to the 1st minus log 2 to the 8th. And so what does it happen to become? Well, I don't have an 8 in any of my numbers up here. I know this is equal to 0, but 8 could be expanded into 2 times 2 times 2, correct? So if I expand that out, I need a parenthesis because it's going to be log 2, 2 plus log 2, 2 plus log 2, 2. And what happens with that? But I can't use these guys because my base is no longer 10. Notice? But what do these all end up equaling? So I get 0 minus, this is equal to 1, that's equal to 1, that's equal to 1, 1, 1, 1 gives me 3. So my true answer to this one is a negative 3. Okay? Again, laws from the previous chapter. My numbers that they give me only go if my base was 10, and since these came out to be 2's, then I end up with that. Okay? We good? What do you think? Okay. Now, as we progress again, we're going to get to where we do not need to work the mathematical piece out with this, but we will see what goes. So if I expand this thing out, what happens to it? So 15 becomes 3 times 5, and the 2 remains on the bottom. We good there? 15 is 3 times 5. So what does this mean? Well, if I expand it, I have log 10, 3, because it's a multiplication in the numerator plus log 10, 5, minus, because it's the denominator, log 10, 2. Okay? We good? What are you guys thinking? Making sense? Hopefully. So then, what happens here is I replace it with what it's equal to. So 771 plus 5, 0.6990 minus the 5, or minus the 2, get the right one here, 0.3010, and stick all those on my calculator, and we should end up with what our value happens to be. I think my calculator so you can see it in there. 0.4771 plus 0.6990 plus 3010. Whoops, my decimal point in there. What was that? Oh, yep. Yep, should be a minus. And now we should be good. And so I get 0.8751 for my answer. These are a little different again than the day before because they were kind of exact stuff when we had 11.4, and these aren't quite as exact. Okay, what do you think? Okay. And then finally the last rule that pertains to this is the power rule. And that says if we have something raised to a power besides x to the r power, we simply bring it in front and multiply. So if you have a power, you're going to multiply it by the log it's connected to, basically. Multiply it by the log. So that's what's going to happen with this one. So the logarithm of a number raised to a power is equal to the product of the exponent and the logarithm. So that's a little fancier than what I was saying, but it still ends up doing the exact same thing. So if you got a power here, bring it to the front and you're good to go. Okay, with that one. So let me flip that one over and see what we can do with these guys. So if I have powers in here, I need to sometimes take a look at them and break them apart. So what happens to this one? What's the power on the shoe if I've got a square root? Good old chapter 9 coming back in here. Means I have log 10 2 to the 1/2 power. Okay, so x power, the square root means I have a half. If it was a cube root, I'd have a 1/3. If it were a 4th root, I'd have a 1/4. So all that stuff from chapter 9 is still infiltrating into this stuff. So it's still there. So what happens here, if I expand this out, that half has to come out in front, and it's going to get multiplied by log 10 2. So if I go to my numbers, and I think they plug these guys back in here again, I would have 1/2 times the value of 2. And what would come out of that for my answer to this one would simply be 0.5 times 0.3010. And I will get my answer of 0.1505 for that one. And once again, it's all involved with rounding stuff if it wasn't an exact half and it didn't go into it. So we'd have to round something in there if it didn't work. Okay, what do you think? Okay, go to the next one. Log 10, 8, but 8 can be broken down to 2 to the 3rd power. And so 3 is going to come out in front. So if I work this one out, it would be 3 times that same value because I still have a 2. And my answer for this one would come out to be 3 times 0.3010. Okay, and so I get 0.903 for that one. Okay, I think you're getting it. Are you getting it? Hopefully. Okay, and then the last one here is log 10, 25, and 25 becomes 5 squared. So that's going to be 2 times log 10, 5, or 2 times what that was equal to, and that's equal to 0.6990. And so I just multiply that. 2 times 0.6990, and I get an answer of 1.398. Okay, so that's what happens with this stuff. Then we're going to get away from not having to figure them out. So we're going to get away from having values and just expanding them out to what they are, and then taking them and putting them away. Now this again has all the stuff that we had in here because we had b to the 1st power was equal to 0. We had, these were the ones from 10 or 11.4. These are the ones from 11.5 today, and that's on your little sheet I handed out to you. So again, to get all of our stuff back together again that we've had with that. Okay, so let's just expand these. These we're not going to answer. They don't have values that we're going to plug in for them, so I can put that sheet away. So let's see if we can expand stuff out in here and see what we have. So I have first go through and read it and figure out what it's asking you to do. I have b, which is my base, 2 times x to the 3rd. So really this means 2 plus x to the 3rd. And then the 3 on the x, because I use all, no, not all, 2 of my rules, rule 1 and rule 3. In this one, I get log b2 plus 3 log bx, because the 3 has to come out in front. What do you think? So again, I'm going to take and look at what I have in here. There's a plus that goes between. The 3's got to come down in the front. What about the next one? That's what you put in Hawks. That will be what you'll type in. Okay. There should be a subscript key where you can put in your base that's in your log. So what about this thing? Yes. Usually you go right in the order that you see them. Okay. Usually you follow where they're at in here and don't reverse them. I guess that's what you're talking about. You're saying if you put this in first and then you put that in second? Yeah. No, usually you go right straight across them and read them from left to right, and you put the first one plus the second one. In addition, it's not really a problem because addition is commutative. You could switch your orders around. So it's not a problem there. But definitely subtraction, when you've got something dividing it that has to be a subtraction, it has to hold its position. Okay? So you can't switch it around. So if we look at the next one in here, log bxy squared, multiplication on top, divided by z. So this means I need to subtract, I need to add, and I need to lower my exponent. Okay, so if you look at these and you write in your little pieces, it should help you out. So I get log b x plus 2 log by minus log bz. Okay, we good there? So again, look at what you've got. You've got x, you've got a square, you've got a minus in the denominator because that's what that division bar means. It means I'm going to subtract it, so I got to get it out of there and move it to where it's supposed to be. All right, let's take a look and see what we got to do with this thing. Now these are, they've got parentheses involved, and they have a square root here involved with the second one. So what does this mean? Well, it means that this -3 is given to both pieces. So if you want to look at that, we're going to give it to both sections of this whole thing. So if you wrote this out as log b x to the -3rd, y to the -3rd, we've got it expanded out to what it could be. So then what does it become? Well, it's a multiplication with exponents, so it's a -3 log bx plus a -3 log b y. And so this sign's going to change in here. It's going to end up becoming a subtraction in there instead of a addition, because that's what happens with my sign. Or you could look at this whole thing and put the -3 out in front, log bxy, and when you expand it this time, you could have a -3 log bx plus log by. So either one of those would be a correct way of looking at that. Okay, so you could expand it and bring it back, or you could put your number out in front and just leave it with it in front of the whole thing. Okay, so two ways of looking at that one. Distribute it or don't distribute it. Yes, no? What do you guys think on that one? Because you got this going through the whole thing, and it's an exponent, so we can bring it out in front of the whole thing. We don't have to bring it out in just in front of one piece. We can bring it out in the whole part, and so that becomes your section there. This next one is log b, but this is really a half. Okay, so we could distribute it by each piece and bring it out in front and have 1/2 log b3 plus 1/2 log bx. Okay, or leave it all together and put the half out in front. Okay, we're going to use this stuff in 11.7 next week. Not right now, but we'll expand some stuff out there or put some stuff back together to come up with solutions. Right now, we're just kind of practicing it for that purpose. So we'll move it back the other way. Questions with this stuff? Getting it expanded to where it should be. Just again, exponents always go out front. Back to back multiplication gets an addition between it, and that's the kind of stuff that happens with those. So now if we have it expanded, how do we put it back to a log and back to what it used to be? So if I look at this piece, when I read across this, what is it telling me? Well, it's telling me that this is an exponent. Okay, that exponent is on x. The subtraction says I've got a division that's happening there. This 3 is an exponent, and it's an exponent on y. All right? So I'm kind of going back, and I'm looking at stuff, and I'm seeing what pieces I happen to have. So now what has to happen is log b is my log piece I have for this. Then I reverse it, so I have x squared all over y cubed. Are we good? Division, because it's subtraction, exponent on y, exponent on x. Now, if you don't feel comfortable hopping right to this, rewrite this as log b x squared minus log b y cubed. Then go back and do your subtraction, and then it will come back out to that. Okay? So if you really want to be careful and watch and make sure you got those exponents where they're supposed to be, rewrite it this way, then put it back as it originally was. Okay? So that's what happens with this piece. Okay, let's take a look at another one. This one's expanded out. This one's got double subtractions in it. So this means divide. This means divide. This means an exponent. Okay? So if I put the exponent back on 4, log b, or a, I guess I should say, log a is my log base. Then I have 4 to the 1/2 power all over 5y, because they're both division pieces, and so they both need to be subtractions. So anytime you got 2 doubles on the bottom, make sure you subtract both pieces. Don't just subtract one of them. And then 4 to the 1/2, really, if I don't know if it's going to ask you to do that, but that means the square root of 4, or I have log a 2 over 5y if you simplified that part. And it may not ask you to simplify it. It may let you leave it this way without simplifying it and getting it to its lowest form. What do you think? Okay, let's see what you guys can do. Well, let's see. This one's still a little bit different, but still same process. Because basically log a is your log. An addition means a multiplication. So on this one, we would have x plus 1 times x minus 1. And I could FOIL that. X times x is x squared. Since it's 2 conjugates of each other, I'm not going to have a middle term. And so it becomes that. Okay? So you'd multiply stuff back and see what happens with it. Questions? Again, I hope it's straightforward. Again, go through and label these. Multiplication, if it's addition, subtraction means it's the other. Now, the reason I didn't break this pieces apart is because they're in parentheses. They're not saying they're separate individual pieces. They have to stay together. It's not like I multiply this times this and this times this and come up with that, because they have to stay together. And so that becomes my solution to this one. Okay, this one. So plus means multiply. So I have log b, the square root of x, times the cube root of x. Yeah, I think you're okay doing that. Now, if we were back in chapter 9, we'd have to take that and simplify it, because then we would have log b x to the 1/2 times x to the 1/3. We come up with a common denominator of 6. So you would have x to the 3/6 times x to the 2/6, or end up with log b x to the 5, 6. But I don't think they make you do that. I think they let you stay here. Again, they may let you do the other way too, so I don't know. Here's the explanation. I guess they do. They make you go down and get it to the 5, 6 because I left the sheet in there of what they ended up doing to it. So they do. They make you figure it all back out again and get your common denominators from your values. So yep, they're going to make you do that piece. And I don't think there's very many, if you run across one, that's in there with that. Leave who up? Oh, this one back? Yep. I can put it back. Sure. And this was find common denominators. This was add exponents. And you end up with that for your final answer. Okay? All right, what do you think? Okay. Then some misunderstandings. Again, these cannot be simplified. They have to stay as they are, and we found that out. If we break this piece apart, it's not times, it's a plus that should go in between those two. And if you have this, it's not looking at it in that format. It's looking at it as a minus in there. So just some common things that might cause us a little bit of difficulty in certain things. So again, they stick those in there to just give you an idea of what stuff happens. Practice problems, are we good or do we need to do some more? Think you're good? Okay. Now these are the ones that, of course, they put in for practice. And if we're going to go and reverse this one out, that exponent needs to go in front and the y gets added to it. Here we're putting it back, so it's 5 to the second power, and this gets divided by 3, and so we end up coming up with that part, and the same thing there, and putting it back together again. So here's the answers to those. If you're watching the video, you can stop it and get those answers in there of what you end up doing to those. So that part's there. And then that's just the practice problem answers. Okay, so just in this section, just be careful if they give you values for log 10, 6, and all those different ones at the very beginning. Usually it's the first problems that you get in this section. Plug in your answers and calculate out what they'd be. Okay, so let's take a 5-minute break and then we'll come back and do that. Well, we'll get done with, let's work on 11.6. 11.6 is using the log keys on your calculator. We're going to use the natural log on your calculator, and we're going to use the things above it. So we're going to use x to the 10th power, that's above log, and we're also going to use our e value that we've used at a certain point in here before when we're doing the formulas in 11.3. We use that e value. And so we're going to use those and calculate out what exact values are going to be. In our case, we're going to round things to the 4 decimal places when we look at these and when we go through and do those. So understanding that base 10 logarithms are called common logs, and they're the ones that have values that we can use and can use our calculator on, because that's the charts and stuff that's built into our calculator. When I was doing my math eons ago, we had books, thick books, about yay thick, that you would go and look in if you were doing logs and had to find and calculate the number, and then you'd put the number in and you'd do different things with it. So it's a lot different today. That big thick book is built into here. So it's kind of neat how that happens, but it's probably built in as a logarithm or as an algorithm in here that solves whatever you put in and stuff. So our textbook had the chart sometimes printed in the back of it, so you lugged around those all the time too. But anyway, so use the calculator to find the values of the expressions or common logs. Then we're going to understand that the base e in logarithms is called the natural logarithm or the natural log, and that is the ln value that's on your calculator. The common logs is the log value that's on your calculator. And then, so then we're going to use the calculator to find those expressions of natural logs. And then we're going to use our calculator to do inverse logs. And inverse logs are when we take 10 to some power and we work with that. And the for the common and natural logarithms, that's where we use the e to the x key is in that one. So we got a little bit to do, but again, this is all plugging in your values and coming up with those. So a little review from the other day. When we turn or turn things into logs. So if I turn these into logs, what happens? Well, I have log, base is 10, the answer is 1,000 is equal to 4. Now, because our base is 10, anytime you have a base 10 that you're working with your log, you can just write that for an answer. And if we put this on our calculator, so let's just do that. Oops, 1,000. Oh, 10,000. Get my other 0 in there. Thank you. If I put that on my calculator and I use my log key, so I'm going to go log, and I'm going to type in 10,000. Close it in a parenthesis. Always get in the habit of closing these things in parentheses. Right now it's not bad, but if you do other things with them and you don't put a parenthesis, sometimes it will add, subtract, multiply, whatever you're putting in there, and do it with that log. So make sure you close them with parentheses. And if I hit enter, guess what I get? I get 4. So that's great. So I should have come up with 4. But there's always, whenever you do these and whenever you see one of these, there is, it's like having a little 10 right in that spot. So you won't see the 10 because they remove it, because again, it's looking at a base 10 log. So if I turn this one around, what's going to happen to it? Well, it's going to become log base 10 answer is equal to a -2 or log 0.01. And we would calculate, if we put it on our calculator, and come up with a -2. So it will come out to be that value that we happen to have. This last one is log 10, 6.3 is equal to x, because I don't know what my exponent happens to be, but I can find it by simply removing, of course, my 10, use my log button, and put in 6.3 and calculate out my answer. And this is one that is, of course, let's shadowing out here for some reason, is not an exact answer. It is a decimal piece in there. So we have to round it off. So if I look 1, 2, 3, 4 decimal places, the 4 is not going to change the 3. So x in this case is equal to 0.7993. So round to 4 decimal places and you will be good to go. Okay, with those. So that's kind of all you do, is just kind of plug them in and go from there and see what happens with what you have. Okay, so here's some other ones that we turn back into exponential form. So again, that little 10 is sitting right there. And so I have 10 to the third power is equal to 1,000. This one, I have 10 to the negative fourth power is equal to 0.0001, and that is a 1. That's there. And finally, the last one, again, that little 10 is always there, is 10 to the x is equal to 4.3. Okay? And when we worked on these in 11.4, we could calculate out and figure out what the answer is. Now we can still do that, because in this case, I would put log 4.3, close in my parenthesis, hit enter, and x in this case is really equal to 0.6335, because I have to round the 4. 6 is going to make it go up to a 5. And that would be my answer. So not too bad with that part. And so you'd come up and stick those pieces in there and get what you have. So we've kind of been using our calculator along with this, with the common log. You have the log key, and then it will appear with a parenthesis, and then you just enter your number, close it with the right-hand parenthesis, and then hit enter, and boom, you are there. Okay, so that's what we've been doing with these things. So it's kind of the easiest section that we've got. So let's calculate out what we get for these things. So what would my value be? So if I have log 200, simply hit log, hit 200, close in a parenthesis, hit enter, and my answer to this one comes out to be 2.301, and it's going to stay a 0. Okay. Always 4. Mm-hmm. Yep. Is it asking for 5? Well, then we'll put the 5th one in there. So I'm going to have a 3. So it did ask for 5. So it's just a matter of rounding to your correct position in there with those. So what happens with this guy? So log 50,000. So log 50,000, parenthesis, hit enter, round to 5 decimal places if it's asking for that. So 4.6989, the 0 is not going to change to 7. So I stick a 7 in and I'm good to go. Okay, with that one. And then finally the last one, same thing. Again, it's just an exercise of plugging them into your calculator, 0.0006, close in the parenthesis, hit my enter, and I get an answer of a negative 3.22184. Oops, nope, the 4 is going to become a 5 with that one. Okay, what do you think? Easiest stuff we probably ever possibly did in here with those. And so that becomes what we do with those. Then if we've got inverse log is, of course, on your calculator. You would go and do second your log key. And if I do that, second my log key, what's going to come up is 10 raised to a power. And these are when we can't figure out what our solution is going to be. It's when we have log x equals some number is when we're going to do these. And so then enter the value of n, close it with a parenthesis, and hit enter. So it's not really a whole lot different than other things that we've been looking at. So the function again, second log, which is going to give you 10 to some power. Then you're going to put in what n is, and then you're going to press enter when you work those out. So let's look at some of these guys and see if we can get them to work out. they're a little different than the other ones. The other ones we had were log some number or some number, and we could calculate those out. These, every one of them gets turned around. That middle base 10 is here, so 10 to the 5th power is equal to x. Would I have to put that one on my calculator? Probably not. We know we've got a 1 with 5 zeros after it if we knew what we were doing with exponents. And so we end up with 100,000 would be our answer to this one. Or if we put it on our calculator, we go second. Let me clear this out. We go second, my log key, type in a 5, hit enter, and we end up with 1 with 5 zeros after it. So we get that answer for what we have there. Okay, so then if we did B, again, that little 10 is right here to the negative 3rd power. And so second, log negative 3. Don't use your subtraction there either. It'll give you an error. And we get 0.001 because we know we move it back 3 spaces. And then C, second, log, because this is going to be 10 to the 2.4142 power. That I can't do in my head. We never had them this big when I was doing this by hand. Thank goodness. But now with today with the calculators, you can basically put in anything they so choose to make you put in there. So my answer to this is 259.53743 when I round that off. Okay, you think you got this? Okay, what's the last one? D. What's the answer to D? There are some of these, and I know D isn't one, but there are some that you put in and it'll say error. And you'll say, oh, wait a minute, I gotta go back and check and see if I put that in right. There are some that just do not work. So do be aware of that some do come out to be errors when you get those. And it will state up above error, and then it will say go to. You'll have a go to in there, but it's just going to be an error, and it'll work out that way all the time. So second, log 16.5, hit enter, and the answer to D is 3.16228 when it rounds it off. Okay. All right, and that's logs. So logs aren't bad. Logs are just what logs are. Inverse log is where, whoops, that's the one we just had. So these are the other ones. So it translates between exponential form and logarithmic form using natural logs. Natural logs are ln's. So I have ln e, same process, base answer equals t. So they reverse exactly the same way, but instead of using a log, we're going to use a natural log instead because of the x or the base of e with these. These you will see as ln 321 equals t, or 3.21 is equal to t. That's how you'll see these. This one is ln e1 equals 0. Or ln 1. They're exactly the same, so you don't have a different value in there. And the last one is ln en is equal to 2, or ln n is equal to 2. And they drop the e, but just remember there's always a little tiny e in there. There's a little bitty e that's always with a natural log, and it always sits right in that spot. Okay, so what would my answers be? So if I did this one, I would hit my natural log, type in 3.21, close it in a parenthesis, hit enter, and I will get 1.16627 for that one. Okay. I pity the poor person who figured all these things out. You know, for me to carry it around in my chart, there had to be somebody who calculated everything by hand at that point. So it's like, whoa. Okay, and then finally ln1. ln, put a 1, close in parenthesis, hit enter, and I get 0. And notice it equaled 0. So that's equal to 0. And then the last one I can't do just yet because it's got an unknown in there, and we'll work with those in a minute. What we have to do with those. Those we have to do like this. You have to use your second and use your e and raise it to the second power to solve those. Okay, so then on a natural log, just what I showed you, you go to your ln key, enter your value, close it with a parenthesis, and hit enter. That's our methodology to solve these. So, and this again, a base of e with logarithms is what we're working with natural logarithms. Okay, so let's see what we get on these guys. We just did that one, ln1. So I put in ln, natural log, type of 1, hit my enter, or hit my parenthesis and my enter, and I get 0. And then if I go ln3, pretty easy stuff, and I get 1.09861 for that one. And finally the last one, ln 0.02, parenthesis closed, equals negative 3.9120 2 when I round it to 5 decimal places. Okay, pretty easy stuff. This section you'll just breeze right through and not have any problems with, I hope, is the thing that you do with those. These are reversed ones. Again, there's a little e that is right here in any of these. If you don't see it, there is a base of e. So if I reverse it back, e to the third power, so if I do a, e to the third power is equal to x. So above my natural log key is where my e is at, and we worked with that a while ago. So go second, natural log, tell it 3, hit enter, and we get an answer of 20.08554. Okay, so that's what that one comes out to be. And then if we do b, is e to the negative first power is equal to x. So second, e, negative 1. Again, use your negative, not your subtraction. And we end up with 0.3678 8. What if I round it? Okay or not okay? Pretty straightforward. And then C is e to the negative 0.1 power. So second, natural log, negative 0.1. And we end up with 0.98, whoops, nope, 0.484. And finally D, what do you get for D? E to the 50th equals X. And thank goodness we have calculators. I wouldn't want to take E at decimal 2.7, whatever it is, to the 50th power. It's going to be pretty good size. And if it comes out in exponential form or in scientific notation, like this one, see how that's got an E in there? You see that? When you enter this into Hawks, you're going to do 5.18471 times 10 to the 21st power. So it is a really gigantic number, okay? So be aware if you get an E, that means the base 10 to the 21st power on your calculator. So if you come back and it says, nope, wrong answer, take another look at your calculator, because when you get going through these and you just zipping through them and you got one that pops up and you got one that shows this, you sometimes don't pay attention to this piece. So you'll get one like this and just put 5 decimal places. You'll get one like that and you say, oh, 5 decimal places. Oh, okay, and type it in. If that happens, it'll come back and say, wrong, okay? So just be aware that you need to watch that last piece at the tail end of it. Okay, so we good with those, you think? Okay. Then it gives you some example problems and practice problems in there, and I think we're okay with what we got going. These reverse it to logarithmic form. These end up giving you the exponent form, and again, in each of these, there's a 10 here, there's a 10 here, and there's an E there. So be careful with those and make sure that you get them in there. And so here's those problems worked out and what their answers come out to be. And I'll leave this up here and get it in line so you can see what those are. If you want to stop it and work those practice ones out when you're watching the tape, you can. And then they give you some more practice problems. Number 9 at the tail end, let's just put that one on our calculator and see what we get. Because in number 9, I've got to do a negative 6.1, close it in a parenthesis, hit enter. This is what I was telling you about that comes out as an error. Number 9 is an error one because we can't do logs with negative numbers in here for those. And I think earlier we were told that we couldn't do that our B values or our values in here had to be bigger than 1. So it comes out error, non-real answer. So all you would write for this one is error, or type in error, or click on error, because it might have a button to click that shows you error. But I wanted to show you that one so that you had an idea. And then the rest of these are just doing what we just got done doing with those. Again, beware, there's a 10, there's an E, just so you get the idea that there is that number that's sitting there with these. So if you have this piece and you got an N here, I have to reverse it. If I have an X here or an X here, these all need to be reversed, okay? Because I can't solve them the way they are. And you'll get in the habit of recognizing those. All of these can be put on my calculator just as they are. And here's the answers to those so that you can see what they all worked out to be. And I have them to 4 decimal places. And I think the answers that they gave within this section are in 4 decimals. Yep, they gave them all in 4 instead of 5 with your homework. So your homework's asking for 5. So just be aware of that you've got those answers in there. Okay, we good with that part, you think? Plug it into your calculator. Just be careful and watch and make sure, remember there's that 10, there's an E, there's a 10. These you need to reverse so that you get your pieces to work out with them. Okay, so that is that section.